How to deal with the problem of space junk. Welcome back to Techstination. I'm Fred Fishkin. Joining us from Rogue Space Systems in New Hampshire is founder and CEO Jeromy Grimmett. Hi, Jeromy.
Hey, thanks, Fred. Thanks for having me.
Well, give us some background to start with about Rogue Space Systems. Love the name.
Well, thanks very much. It was all actually born out of a research paper that I wrote in school. And after some encouragement and a visit to the MIT Space Conference, I decided to start what is now Rogue. I recruited a couple of co-founders to try to help me out. And here we are a couple of years later, and things are going extremely well for us.
Well, tell us about it. What is the mission?
Well, what we've decided to do, as opposed to being entirely focused on just space debris removal is an analog to performing satellite servicing and being able to repair satellites and create a more sustainable environment within space. So at the very beginning, we were very focused on space debris. But what we figured out was that the market was not ready. It wasn't prepared to pay a private company, or any company really, to remove space debris. Not even the insurance companies were very interested. So we sort of pivoted to satellite servicing and creating a more sustainable environment there, so that we're not having to create more debris through the proliferation of more and more satellites, being able to repair, reuse, refit satellites, or maybe even take them to higher orbits, help them with station keeping. Then in late 2020, we had we had the Space Force reach out talking to us about, hey, can you do something about space debris, after General Thompson had said, you know, we'd really like to do something about space debris. We're going to pay commercial companies to deal with it. So over the past year and a half or so, we've been very focused on ISAM, which is in-orbit service and manufacturing, which encompasses our role and our mission of repairing and fixing satellites and removing space debris.
How do you go about doing that?
Very carefully. It's actually a very complex process to go and grab another object in space. You see, everyone thinks that in space, the object is just sitting still. So take my cell phone, for example. It's just sitting, floating in space in this static movement as it flies around the Earth, okay? Well, the reality is this object that's flying around in Earth, it's not necessarily static. It could be turning and twisting. It could be rotating on its various axes. So the complication is, how do you deorbit something? How do you grab a hold of something that is moving and tilting and pivoting? That's where the real complications start coming in. And we've been very fortunate that we've been able to work with University of Utah on some magnetic de-tumbling technology that uses magnetic eddy currents that passes through the object in order to slow it down on those axes so that we can safely approach and then grab it.
So are you constructing, is the idea to build a vehicle of some sort that would be launched to take care of these issues?
That's correct. So right now we're working on 3 to 4 different spacecraft. They're all iterative in design, so they will progressively get more and more complex over the next couple of years. The first one is called Barry. It's a very small spacecraft to do some demonstration. The next one up is Laura, which is an inspection observation system. where it can get very close to another object in space and then take pictures and perform all kinds of different diagnostics. Then the third one we're looking at is potentially called Charlie, which has some iterative robotics equipped to it. And then finally, there's Fred, which is a very large 325 kilogram spacecraft with 4 robotic arms, 4 kilowatts worth of power, and capable of grabbing a hold of other objects in space or attaching things and stuff like that.
Where are these names coming from, Jeromy?
Well, we, as a startup, you have to look for pretty cheap office space. So we're in the top of an old mill building, and we have a bat that flies around our office. And we named the bat Barry. So he actually still flies around our office. Laura is after my adoptive mother that passed away a couple years ago. Charlie's after a co-founder's father that passed away over the past couple of years, and then Fred is after another co-founder's father-in-law that had passed away. So what we've tried to do is we've tried to humanize things, with the exception of Barry. We tried to humanize things as opposed to going after or using a bunch of acronyms that really don't mean anything. We tried to inject a little bit of humanity into each robot.
Where are you in the process of turning this into reality, having a vehicle?
So currently, Barry is almost ready for flight. We're looking at a launch here in the next several months. That he's going out. We're already manifested. So he's going up very soon. Laura is supposed to go up in May. And then Charlie, his design has not started quite yet. There's some early concept of him, but Fred's design has actually already started. So we're kind of marching through everything simultaneously.
And do you have a contract already? Who's going to be launching it? And tell us how this will all come together.
Yeah, so we're currently contracted with SpaceX, and they're going to be putting it on their transporter, on the various transporters that they're sending up over the course of the next 8 to 10 months. Now, that'll be for the Barrys, Freds, and potentially the Charlies. When it comes to Fred, that's a whole other system that'll have to be within the stack in the payload fairing. That's not something that would be on one of the ports. It would be within the stack. So with that being said, we're targeting for the end of 23, early 24 for Fred. It's a pretty aggressive schedule, but we think we might be able to get there. Or at least we're going to give it hell and try. As far as customers are concerned, Space Force has been funding us for the past several months. We just won 11 STTRs for a total of about $2.5 million in funding. And we're using that to increase what's called our TRL, our technology readiness level, and accelerate the improvement of these different techs so that we can get to space and start solving these problems.
Who are your chief competitors in this arena?
Well, there's a couple of international competitors, such as Astroscale, ClearSpace. Those are the two really the main ones internationally. Really, Astroscale. It's hard to compete with 400 million in funding over 10 years. They're doing some pretty interesting stuff. We're moving a little bit faster than they are, or at least our plans are far more aggressive. The other side of this coin is the US market and our US competitors. companies like Turion, Starfish. In terms of startups, those are the ones that are most competitive.
So I guess one of the questions that comes to mind would be, what do you do with this stuff? I mean, you don't have a recycling can floating around up there to put it in.
It's funny you should say that, because that is one of the concepts, one of the things that's being floated out there is repurposing old satellites and trying to create an in-space economy to recycle this stuff or reuse it, refit it. That's one of the things that's been floating around the industry, is how to really deal with that. The alternative really is just send it down and burn it up in the atmosphere on reentry. That's normally what we would do. That's how it's done now. If there's something that's really old, they make a maneuver. If it's in low Earth orbit, they simply send it on a trajectory so that it burns up upon reentry. If it's at one of the higher orbits like geostationary, then they increase the altitude to what they call the graveyard orbit, and it just sits out there because it's not going to get to Earth for like 500 or 600 years.
But with what you're going to collect in terms of some debris and such, what happens to it?
Well, that stuff, we would probably send it to burn up through the atmosphere. That's probably what we would do. We would attach something to increase its drag, or we would grab it and pull it down to burn it up. Because there's just not there's no market for recycling right now in space. There's no facility to actually do that. One of the things that we did talk about here at Rogue is trying to set up a bit of a depot where we'd be able to store this stuff. But then you get into intellectual property rights and salvage and things like that, where companies, space companies, don't really like giving up their intellectual property or surrendering that. So you got to be able to protect that. And it's like anything else, you have document destruction, same basic thing, protecting intellectual property and preventing competitors from flying up and looking at your stuff, or even adversaries.
Very interesting. So tell us about the need for this. If we don't do anything, what's the problem?
There's a theory out there. Well, it's called the Kessler Syndrome, where it was depicted pretty well in that movie Gravity with Sandra Bullock, where she impossibly finds her way back to Earth. So where one object collides into another and it sets off this massive pinball effect, where things are just constantly blowing up and exploding. That's the big fear for space, because it would become near impossible, or impossible really, based on what we have today, to actually clean up that debris if something should happen, if something like that should happen. Well, we're not there yet. The idea is to be proactive and prevent us from getting there. There's a lot of junk out there, and as long as we start acting soon, we'll be able to create a very sustainable environment out there and prevent these problems. Primarily, our big customer to date right now is the Space Force, and maintaining access to the domain for national security purposes.
What kind of junk? What's floating around up there that might surprise us?
Everything from tools to astronaut gloves to old dead satellites, rocket bodies. I mean, somebody's thing of Tic Tacs that fell out their astronaut suit. I mean, paint flecks, just nuts, bolts, and satellites the size of buses. I mean, it's all up there. all of it's up there.
Where can people go for more information about what you're doing?
So you can go to rogue.space, check us out on YouTube, any of our social media outlets. We're always posting a video or more knowledge about the various concepts that we're working on, or just reach out. We have we got a team that's dedicated to sending information out and helping people understand the problem. So always feel free to shoot us an email at info@rogue.space.
Finally, what in your background led you to this? Was it Star Wars, Star Trek, or what brought you into this realm?
Well, I mean, every kid's got their space story. Everyone that's in space has their when I was a kid type of thing. And I'm no different than that. I just happened to be in a position a couple of years ago to make a decision, because it's always been something I've wanted to do, never knew how to get into it. And I just happened to be in a position where I was able to exercise that initiative. And I've been very, very, very lucky to been able to get a team surrounding me that's been able to help me execute that.
Terrific. The site again is rogue.space. Jeromy Grimmett, thank you so much for taking the time with us.
No problem, Fred. Thank you again for having me, and watch out for that space junk.